Okay, so we're going to be talking about molecules, and that's basically the start of chemical reactions. So the video that we have here is a thermite and ice reaction, which is pretty neat, so let's take a look. Okay, so that was a thermite and ice reaction, and that's two different kinds of compounds that, when brought together and introduced to heat, give you a nice big explosion. So we're going to be talking about the basis of what that means as far as compounds and that kind of stuff here in chapter 5. So how atoms form compounds is what we're looking at. First, we need to look at what a compound actually is. And a compound is a pure substance that contains two or more elements. So when you look around you, most of the matter around you is made of compounds. It's really rare to find a pure element. It's gold pure gold is pretty rare as compared to something like salt down here at the bottom. Things exist as compounds because they're much more easily made in that format. So here we've got a couple of examples of common chemical compounds. You have water is a compound, carbon dioxide, which you breathe out. Ammonia is a common cleaner, so that stinky stuff under your sink, and then hydrogen peroxide that your mom might put on your cuts. And then also we have table salt, NaCl, and sugar. And right now you should have your notes, chapter 5, lesson 1. So I want you to draw an example of a compound here. It can be any of those things from the PowerPoint here. Any of these is fine. Next is a chemical formula, and a chemical formula contains atomic symbols and subscripts to show the elements and the number of atoms of each element that form a compound. So it basically is a mix of letters and numbers that tell you what is in each compound. So the atomic symbol I have here is the letters, symbols of the element, and a subscript is the little number to the bottom right of the element symbol. And those tell you how many atoms of hydrogen are in this chemical formula. So this is a chemical formula for water, H2O, which means it has two H atoms and one O atom. Next is a molecule, and a molecule is a neutral particle that forms as a result of electron sharing. So basically means that it has no overall charge. And here it shows you that these are little semi-charges that are formed by the sharing of the electrons, but the overall charge of a molecule is neutral. It's not an ion. So one type of molecule formed by electron sharing is water. So you should have on your notes the chemical formula for water from the last slide was H2O. And then I want you to draw me an example of a water molecule, which is this right here. Okay, so a molecule basically you get from electrons being shared between different atoms. Okay, and that is why it's neutral, because they're shared. So the next thing we have is an ionic bond. And an ionic bond is an electrical attraction between positive and negatively charged ions in an ionic compound. So we learned about ions in the last chapter. And you know that you can get positive and negative ions depending on what happens with the electrons. So positive ions are attracted to negative ions and vice versa. Opposites attract. So what we're talking about here is in this portion and this portion. We'll go over more later, but ions in group 1 of the periodic table, which is the hydrogen column up and down, give up their outer electron and become positives. And then the ions in group 17 gain 1 electron to fill their outer shell and become negative. And I have 2 examples here. One is salt and one is magnesium fluoride. Next is valence, and this is something that's really important as we go on, so we really need to pay attention. How we're going to show valence is through Lewis dot diagrams, and these diagrams the valence electrons of an element. So the valence electrons are an atom's valence is the number of electrons in its outermost energy level. So what you're going to do is find the row that the particular element is in and count over boxes to find the number of valence electrons. So we're going to do this for oxygen. And you can see here that it has 1, 2, 3, 4, 5, 6 little dots on it. That's called a Lewis dot diagram. You put the symbol and then you diagram the number of valence electrons it has. So if we're looking at the periodic table here, we have oxygen, and we're going to go over how we get the 6 Lewis dots for the Lewis dot diagram. So the valence electrons basically are the ones in the outermost energy level. So if we take oxygen, we know that oxygen has 8 electrons based on the fact that 8 is its top number. And 2 of those electrons can fit in the first shell. And then you have 6 electrons in the second shell. The way you can figure that out without just having to do the math or think about it is to count over boxes. So you start on the left with lithium, you find the row that oxygen is in. Oxygen is in this second row right here. And you count boxes. So you go 1, 2, 3, 4, 5, 6. And that's how we get 6 dots on our diagram. And you start with 1 here and then 2, 3, 4, 5, and 6. Okay, and they like to pair up, so that's how we have them in pairs. And we'll go over more about valence electrons when we do some more notes. But basically, you just need to know how to find them. So make sure that you know to do valence electrons. Say if we wanted to do aluminum, you would find the row it's in. 1, 2, 3 valence electrons for aluminum. So to find valence, you go to the row it's in, start on the left, and count boxes, and that's how many valence electrons are in its outermost shell. Those are the electrons that are going to be the ones that react with other atoms. Then we have a covalent bond, and that's a chemical bond formed when atoms share electrons. It can be confused with a molecule because this is just a bond that holds those molecules together. So here we have an example of hydrogen is a +1 in the middle of the nucleus. It has 1 proton and 1 electron, and it looks like this if you were to draw a little diagram of it, Lewis dot diagram. And then when you have 2 of them coming together to form a covalent bond, they share, each of them share their 1 electron. So now they have a full first shell, right? Because they're sharing and the first shell can hold 2. So that is a single covalent bond. And you can also have double covalent bonds and triple covalent bonds. And these bonds get stronger the more of them you have. So what I want you to do on your notes now is to draw an example of a covalent bond. Okay, and I would recommend using this right here. The hydrogen, draw me the atom like this, and then the Lewis dot diagram right underneath it, and then draw me the 2 atoms sharing the 2 electrons and Lewis dot diagram for that. And make sure that you draw the Lewis dot diagram of O from this slide. Okay, so that is the end of our video for Chapter 5, Lesson 1. Make sure that you have this done for class, and I will see you soon. Bye.